Alright, today we're going to talk about section 7.4, which is going to be working more with radical operations. We're going to talk about something called rationalizing the denominator. But before we do that, we need to make sure that we can distribute and FOIL and combine like terms appropriately. So pause the video here and take a couple minutes to solve the first three problems here. Okay, so go ahead and check your first three problems here. Again, all we're talking about here is distributing. In number one, we're just distributing the x to the two terms. And for 2 and 3, we are foiling. If you notice in number 3, because this was factored, this is really factoring dots, so it's reverse, and so those middle terms cancel. So let's go ahead and practice them using radical expressions. For this first example, we need to distribute the cubed root of x, and we can multiply these together because they are both cubed roots. So when we multiply the cubed root of x times the cubed root of x to the third, we will still get a cubed root, but then we have two x's here and another x here, which means we will have x to the third. Then we distribute the cubed root of x to the last term. We will again have a cubed root. It will be 2 times x, giving us 2x. And we can simplify in here, because remember, when we are talking about a cubed root here, that means we need 3 of something. Well, we have 3 x's. 3 goes into 3 one time. We can pull out our 1x. There's nothing we can simplify over here, because 2 is prime and there's only 1x, so it will stay. Second example here, we're going to talk about foiling. So we're going to multiply the square root of 5 times the square root of 5, and we'll get the square root of 25. And we'll take square root of 5 multiplied by negative 1, we'll get negative root 5. And then the inside here, we get positive root 5. And then on the last ones, we get negative 1. You can see, just like a previous example that we talked about, the middle terms will cancel. And then we can simplify the square root of 25. That is just 5. So that's 5 minus the 1, which simplifies to 4. So go ahead and pause the video and take a couple minutes and practice the next two examples. Okay, for the first one here, we need to make sure that we are taking 2 square root 5 minus y. If we're squaring it, we need to multiply it by itself. And so we have a FOIL problem. First terms, we're going to get 4 square root of 25. Next, we'll take 2 root 5 and multiply it by negative y. We have to keep the root 5, so we have negative 2y, and then our root 5. Inside here we have another negative 2y, root 5. And then our last one, we have a negative y and a negative y, so we have positive y squared. Remembering we can only combine if they are the same here, so we have a y root 5 and another y root 5. They are negative 2 and negative 2, so that will combine to a negative 4y root 5. Here the 4 times root 25, that's really just 5, so 4 times 5 is 20. And then we have our y squared. For the next example, again, FOIL, start again, 8 and 8, you'll get 64. Multiply those two, you are going to get 24 root x. Then on the inside, we're going to get negative 24 square root x. And then the last, because this is negative 3 and positive 3, we're going to get negative 9 square root and an x times an x gives us x squared. The middle terms will cancel. And let's get 64 minus, then the square root of x squared simplifies to just x, and we need to make sure that we have the absolute value. Next, we're going to talk about rationalizing the denominator. When we're doing that, we're going to try to relocate the radical from the denominator to the numerator. And when we are doing that, what we really need to think about is we're going to multiply to complete the root in the denominator. And whatever we multiply the denominator by, we will have to multiply the numerator by, but we're trying to get rid of the radical in the denominator. And so we look at the first example here. We have the square root of 5 in the denominator. We want to get rid of the square root of 5. So that means we need another square root of 5 in the denominator. So I'm going to multiply the bottom by the square root of 5. Whatever I do to the bottom, I need to do to the top. Because I know that the square root of 5 times the square root of 5 is going to be the square root of 25, which is just the number 5. And then on the top, 3 square root 5 stays as 3 square root 5. But I have successfully relocated the radical. It's no longer in the denominator. It is okay that it is in the numerator. The fourth root is a little bit more complicated. So when I think about this one, I need to think about what else do I need to complete the root in the denominator. So when I look at this one, I have a fourth root, which is important. I need to make sure I identify that I have a fourth root, which means I need 4 of something in order to eliminate it. Well, down here I only have 1, 2. In order to eliminate that 2 inside the radical, that means I need 3 more 2's. So you might be able to shortcut it, but I'm going to write it out. That means I need 3 more 2's in the denominator, because I need a total that 4. If I have only 1 x in that fourth root, that means I also need 3 more x's to give me a total of those 4 x's. Now whatever I do to the denominator, I must do to the numerator. And it is a fourth root. All I've done is copy the denominator back to the numerator. Again, you might be able to shortcut some of this work. So what this looks like written out, so I have 3 2's on top and 3 x's in the numerator. In the denominator now, I have to multiply both of these. Together, I have 4 2's and 1, 2, 3, 4 x's. And the reason why I was doing this is because I need 4 of something. Down here, the fact that I have 4 2's means I get to pull out a 2. And the fact that I have 4 x's means I get to pull out an x. In this case, I do need to be in the absolute value. You can root to the odd exponent. So I have successfully gotten rid of the radical in the denominator. Now the numerator is whatever it is left. It is a fourth root, and I have 2 times 2 times 2, so I have 8, and then x to the third. We'll do a couple more examples here. This first example, if you can ever reduce it, you may always do that first. So this one will simplify first to the cube root of 1 over the cube root of 2. Remember, you can split it up into each separately. So now, when I think about trying to get rid of the radical in the denominator, I need 3 of something. What do I need to multiply to complete this root? Well, I only have 1 2. That means I need 2 more 2's in order to get rid of it. I need to multiply by the cube root of 2 times 2. That will now give me a total of my 3 2's. If I do that to the denominator, I must also do that to the numerator. So now my denominator will simplify because I have the cube root of 3 2's. So that will just simplify to the number 2. Successfully have gotten rid of the radical in the denominator. As far as the numerator, I have 1 times 2 times 2, which is 4 inside my cube root. In the last example, remember we're trying to rationalize the denominator. So if I think about what the denominator is written out, it is really 3 times y times y times y. And because I am taking the square root, there's no number here, so it's really just a square root. That means I need a pair of something in order to pull it out. Well, I only have 1 3. So in order to eliminate the square root in the denominator, I need another 3. I have a pair of y's, and then I have a y left over, which means I need 1 more y to give me a pair of y's. Whatever I do to the denominator, I must also do to the numerator. So I will multiply the top by square root of 3y. So now if I were to multiply this out, my denominator now looks like the square root of 3 times 3 and 4y's. The top is the square root of 4 times 3 x to the 5th and y. Now I simplified this the way I would simplify any problem. I have a pair of 3's in the denominator, so 3 comes out. A pair of y's and another pair of y's, so it's y squared. As far as the numerator is concerned, the square root of 4 is 2. 2 goes into 5 2 times. And I'm left with 3x and y inside of the radical. This is definitely a challenging concept, and it requires some practice with simplifying square roots, cube roots, fourth roots, and remembering that we need to understand we are looking for what it is that we need to multiply to complete the root in the denominator. So please practice those problems and use the remainder of the time to do that.